Learning outcome 1, refraction, and notice the spelling refraction. Refraction is the change in speed that occurs when light, or any other way for that matter, travels from one medium, which is a phrase remember we use for whatever the light or the wave is travelling through, to another. If the definition is a change in speed, it's worth noting that the wavelength also changes. So during refraction, both speed and wavelength change. And direction in most cases. With the one exception being when it strikes the surface at right angles. A new page for learning outcome 3. It's important we get this diagram right. I'll try and keep it nice and large. If you kind of squeeze it in, then it's more likely that you'll miss the kind of important details in it. So we're looking at refraction using an example of a rectangular block. Let's take up a wee bit there. And we'll do the ray in a different colour. We look at a ray coming in at an angle. And where it strikes the first surface, we have refraction occurring the first time, and we have to draw a normal. And if this was from air to glass, for instance, then it would bend towards the normal. We'll mark these angles in a wee second, but the angle of incidence gets smaller. Sorry, the angle gets smaller from the angle of incidence to the angle of refraction. We'll explain these abbreviations in a wee second. And then, so that's the first incidence at the first surface, but when it strikes the second surface and goes to leave, then refraction occurs again. So we have to draw in a normal again at that point, and it will bend away from the normal if this was something like air to glass and back to air again. And at our second surface, we have another angle of incidence and another angle of refraction. So we'll mark these incidences. There's refraction 1, and there's refraction 2. We'll define these abbreviations in that we've been using. Capital I stands for angle of incidence. An easy way to remember that is the angle it goes in at each surface. And capital R is the angle of refraction, the angle it refracts at. Now, one other thing worth noting, that for a rectangular block, so it's not true for all shapes, the final ray will be parallel to the original ray. And that's the final ray up there. That one there will be the final ray. That one there is the original ray. So refraction occurs when it enters and leaves. In this diagram here we've got two instances of refraction. On entering what we call a more optically dense medium, e.g. going from air to glass, the ray bends towards the normal. I.e. the angle of refraction will be smaller than the angle of incidence. Like that first surface there, angle of refraction, smaller than the angle of incidence. On leaving a more optically dense e.g. if going from glass back into air, the ray bends away from the normal. I.e. angle R is bigger than the angle I. The angle of refraction is bigger than the angle of incidence.